All right. It is day 17 in geometry, and we're starting unit 3, quadrilaterals and polygons. So for your do now, I gave you this little paper, and it says you will need scissors and glue or tape. And then you were supposed to follow the directions on the activity sheet and then answer the questions below. So we're going to start with the activity sheet. And the directions told us cut out the shape along the red dotted lines, then cut along the black dotted lines to separate angle A, B, C, and D. So one of the first things I'm actually going to do that I didn't already do is I'm going to put little angled arcs on each of these angles. If you already cut your shape out, that's fine. You can do it on your cutout shape. I know, sorry. I'm just gonna do, it's okay if you don't do it the same exact way. I'll put 1 arc on A, 2 on B, 3 on C, and 4
because they're all different.
On D, yes. And we're putting a different number of arcs because these angles are different. We don't know if they're the same, so we assume they're different. So we're cutting along the red lines. I'll try to do that quickly here. Let's see.
These go together.
And this might remind you of our triangle activity, where we cut out a triangle and put all those angles together. So now I'm going to cut the black dotted lines. Okay, so now we have 4 pieces. So after cutting out all the shapes, arrange them so that each angle, angle A, B, C, and angle D, shares a single vertex, and the red dotted lines are up against each other. Now, I cut off the dotted lines, so that's not helpful. But we're going to line up the angles. So I'm going to go back to my do now paper, and let's put them together. So here's A, here's B, C, here's D. Okay, so what I'm going to do here is straighten them up by taping them down. So,
Excuse me.
yes.
They don't fit.
They don't fit. What you mean?
This ain't no shape of nothing. It don't fit at all.
Doesn't make a shape,
It's a weird thingy.
but the angles are going to fit together. Now, I cut mine probably a little crooked, so it's not
I
perfect.
get that, but you hurt my brain with this one, and it did not fit.
He kept rearranging it.
I'm trying to match edges up and stuff. Yeah.
Okay.
Yeah, it broke my brain too, so I remembered. Oh yeah, this does not make a thing.
That's okay. So let's we've done this part. Let's look at these questions. So to clarify, number 1, how many sides does the original shape have?
4.
4. Okay, so let's write 4. The original shape. The new shape is all over the place. How many angles did the original shape have?
4.
4. Okay, now number 3 comes from this new thing we just made. Estimate. That means make a guess, an educated guess. What do you think the sum meaning we add them all together, What do you think the sum of the shape's angle measures is? These angles, these four angles.
360.
360. What makes you think 360?
It does a circle.
It makes a circle. Guys, yes. Okay, so 360 degrees is the correct answer. Now, if we want, can't remember, I think you guys have these at your tables, these protractors. If we wanted to, we could start with angle A, line up on the vertex, that point in the middle. Let me zoom in. And we could see here that angle A goes all the way around, opens up, going into angle D, angle C partially. We're at 180 degrees here.
Uh-huh.
If we continue that, flip this around, from where we left off, we go back around another 180 degrees.
Yep.
180 plus 180 is 360. So we have in this shape 360 degrees. Now, we just talked about a shape that has four sides and four angles. This is going to take us to our first page of notes. We're going to talk about this. And this will work on any shape with four sides and four angles. Those angles add up to 360 every single time. So get out your notebook. Again, if you do not have a notebook and you need one, we have lots of extras at the front of the room. Feel free to take whatever you need. And this activity was just as a demonstration. If you want to keep it, you can. If you throw it away, you're not going to hurt my feelings. But I'm going to put this to the side, pull out my geometry notebook. Start page. So, geometry. Unit 3. And our title is going to be Quadrilaterals. A long word. Quadrilateral. Quadrilateral. And polygons. And that's what this unit is going to be all about. Also just going to add a little title on top that says Day 17 Notes, because that is the day that we are on. One. Okay. We're going to start with a definition of quadrilateral. Today we're focusing on quadrilaterals. We'll get to polygons in a bit. So, first, I'm going to make a little star, a little bullet point, and write that word quadrilateral again. Quadrilateral. So a quadrilateral is a closed shape, meaning all the sides are connected. A closed shape that 4 sides and 4 angles. The 4 angles always add up to 360 degrees. So I'm going to write here the 4 angles. These angles always add up to 360 degrees. Okay. So a quadrilateral can look like many different things as long as it follows these rules. And on a sticky note, for example, I might have a quadrilateral that looks like a square or a rectangle. Maybe it looks like a diamond. Or maybe it looks like something strange. As long as it has 4 sides and 4 angles, for example, if here's one long side, and maybe I'll do a short side here. Maybe another short side here. Another one there. That's a quadrilateral. It's got 4 sides. And it's got 4 angles. Now this is now that's something different. Now a quadrilateral is very general. It just tells us how many sides and how many angles. That's really it. We're going to get into some more specific quadrilaterals today. And the first category we'll talk about is called a parallelogram. So I'm going to write this in big green marker. I'm going to write E-A. Parallelogram. Parallelogram is a type of quadrilateral. So we already know that a parallelogram will have 4 sides and 4 angles. We know those angles will always add up to 360. But there's certain things that have to be true for a shape to be considered a parallelogram. And here are those rules. There's rules to parallelograms. The first rule is that opposite sides are parallel and equal. Now, instead of writing parallel, I'm going to write the symbol. This symbol means parallel. Parallel. And equal. Opposite sides are parallel and equal. We'll say opposite angles are equal. So say consecutive, which I'll explain what that means in a minute. CONSEC, consecutive angles are supplementary. Does anybody know what supplementary means? We didn't focus on it a whole lot in our angles unit, but supplementary means that they add up to 180 degrees. So I'm going to put that in parentheses. Add up to 180 degrees. And we're going to draw a picture of a parallelogram below this. So I'll give you guys a second to get these rules written down. I'll pause this. And then you're going to want a ruler for the next part. So we're going to draw a parallelogram here. And what we'll start with is two sides that are the same length, so that are equal and that are parallel. And remember, parallel just means that they are going at the same angle. So I find it easiest to start with these sides going left to right. So I'm going to make my first side start on the red and blue where those lines on your paper intersect. And I'm going to make my first side length 7 centimeters. Just like this. And what we're going to do after you've drawn that first 7 centimeter side is you're going to move your ruler down the paper and over a little bit. It doesn't matter how far over you go, but this second side we draw must be the exact same as the first one. So I'm going to do another line that's 7 centimeters. Just scoot it over a little bit. Like that.
That way
Tilt
you
it.
can connect them.
Yep. Once you've got those two sides, we're just going to connect on the edges here. It looks like my edge is about 3.6 centimeters. Yours may be different, and that is completely fine. But these two shorter sides must be the same length. My other one is the same, about 3.6 centimeters. Just like that. So here's our parallelogram. And once you've got that drawn, we're going to label our shape. We're going to start by showing that our sides are parallel and equal. So I'm going to highlight that parallel part with red. And we're going to show that they're parallel on the shape with red. And the way to show that lines are parallel is we'll put little arrows on them. So I'll start with my longer sides, top and bottom, and I will put 2 little arrows right here. And I'll do the same on the bottom side. 2 little arrows. These are parallel because they're going at the same angle. We'll do the same with these shorter sides, but I will just use 1 arrow. And it's just like how we only put 1 arc on angles that are equal, but if one has 1 arc and another one has 2 arcs, they're not equal. The side with 2 arrows is only parallel to the other side with 2 arrows. So we want to put a different number of arrows on the other parallel sides.
Makes sense.
Yeah. Now I'm going to take another color, I don't know, purple. And we want to show, I'm going to highlight that equal sign with purple. And I want to show that my opposite sides are equal. So we do that with tick marks. So on my longer two sides, I'm going to put 2 tick marks. So 1, 2, 1, 2. That shows that these sides are the same length. On my shorter sides, we'll do 1 tick mark. So the shorter sides are the same length. Okay, so we've labeled our sides. Now we're going to look at the angles. So I'm going to use a third color. I'll use green, and I'm going to highlight the opposite angles that are equal. So first we'll label our angles, and we'll just put A, B, C, and D. So I'll start here on the bottom, or you could start anywhere really. A, I'll make that a bigger angle. I'll go up and label this one B. Over, that will be C. And down, this one is D. And to show that our opposite angles are equal, we're going to use arc. So starting with angle A, this is my bigger angle, so I'll just use 2 arcs. Which angle is opposite of A?
C.
C. So C also gets 2 arcs. They're equal. Then we've got B and D that are opposite. So we'll give them 1 arc because they are also equal to each other. Finally, we're going to talk about what consecutive angles are. Yeah, those. We know opposite just means that they are right across from each other, like A and C or B and D. Consecutive means they are right next to each other. So, for example, A and D are consecutive. So if we wanted to make a little note, consecutive means next to each other. So I'm going to write over here consecutive, C-O-N-S-E-C-T-I, consecutive equals. So for example, we'll start with A, and the angle next consecutive would be B. So consecutive angles add up to 180 degrees. I could write A plus B equals 180. I could write B plus C equals 180. C plus D equals 180. I could also write D plus A equals 180. If I were to write an equation that said A plus B plus C plus D, what would my answer be for 360? Good. Those 4 angles, this is a quadrilateral. They always add up to 360. Perfect. Perfect, perfect.
Yeah.
Now we can use this information to help us solve for missing angles, for example. And down below, I'm going to put an example here. Let's say angle A is 120 degrees. If I know angle A is 120 degrees, can I use that to find the remaining three angles, B, C, and D? Yes. Yes. What are you thinking? What could we do?
So angle A and angle C are equal.
Yes.
So angle C is also 120.
Perfect. Angle A and angle C are opposite, so they are equal. So right off the bat, without doing any work, I know that angle C is also 120 degrees. They're opposite, so they're equal.
And then 180 minus 120 gives you your other two.
There you go. If I find B or D, either one, I have the other because they are also equal. So just like you said, I could kind of write a little equation if I wanted to. I know A or 120 plus B equals 180. So really it's like 180 minus 120. If you're interested in the equation, I'm going to write that out as well. Since I know A plus B is 180, A plus B, 80. A is 120 plus B is 180. If we were to solve that, we'd subtract 120 from both sides. We would get B equals, what's 180 minus 120? 60. 60. Perfect. So angle B is 60. And B is equal to D, so D is 60. Not too bad. Pretty good. Pause this for a second, see if I can find this paper. All right, so I just passed out this worksheet right here. Angles in quadrilaterals, and I am going to write at the top of my page, day 17 worksheet. And on this worksheet, notice it says quadrilaterals, not parallelograms. So some of these shapes could be parallelograms. Some of them are just quadrilaterals. They don't necessarily all have the opposite sides that are equal and the opposite angles that are equal. But we can use everything we just wrote down to help us solve for any of these problems. So looking at number 1, let's see. We're going to find the measure of the angle that's indicated. So we need to find angle W. I know that because it has 4 sides and 4 angles, that all 4 angles add up to 360 degrees. Is there anything we notice about number 1 that can help us?
2 angles are the same.
2 angles are the same. There's 2 angles labeled with 100 degrees. Okay. So if these 2 angles are the same, we might think these 2 other angles could possibly be the same as well.
Mm-hmm.
Now, because this worksheet doesn't have labeled 100% that this is a parallelogram, it's never a bad idea to just be certain. Let's start by adding the hundreds together and the 80. Let's add these three together. So 100 plus 100 is 200 plus 80 is 280. Okay. Now, if I know all four angles should add up to 360, how could I use this 280 to help me find W?
Plus W equals 360.
Yes, yes. This number plus the missing angle should equal 360. So let's subtract 280. Bring down our W. And what is 360 minus 280? Would be 80 minus 200.
Then you take the 6 from
Yeah,
there'd be an
you're
extra
right.
20 left over.
Perfect. We get 80. Okay, so this is a
I
parallelogram.
thought I just did that mentally.
Pretty good at that.
So yeah.
So this is a parallelogram. Wonderful. Now, I wish that this worksheet would give us those opposite angles are equal or opposite sides, because that would have been a lot faster to not have to do that math. But you never know. You never know.
I don't think it put that there because some phone are not.
Right.
Yeah, and so then we have to say this one says this one.
Right, right.
So if it's either just did that.
Right.
Okay, so that was number 1. Let's look at number 2. This is definitely not a parallelogram. Does anybody have an idea of how we could begin to solve number 2 for that angle D?
You put it in an equation.
Yeah, we could put it in an equation. What equation?
120 plus 95 plus 85 plus D equals 360.
Good. I know A plus B plus C plus D equals 360, so we'll plug in the values for A, B, and C plus D, and that should equal 360. And once our equation is written, what are we doing now?
In like terms.
Yes, let's add our like terms. So 120 plus 95 plus 85. It is 300. Good. So 300 bring down plus D equals 360. And now what?
You subtract the 300 from both sides.
Good. Minus 300. And D equals 60. Perfect. Good. That's not too bad, is it, you guys? That felt pretty easy.
Yep.
Okay. Okay.
Now, if it was on courseware, it would have put in
Yeah.
I don't. So
Right.
stressful.
I know. I heard it was not fun.
Of course, we doesn't actually teach you what
Yeah,
you need to
you have to-
put the equation, have you read up a bunch, maybe give you a picture, that's about it.
You gotta read it and teach yourself. So we're gonna flip to the second side of this page or of this worksheet and see where it can get a little bit different. For example, number 9. Whoa, there's an X in there. We're gonna solve for X, but we're still going to use the same process. We're adding the 4 angles together. We're setting them equal to 360, except now, instead of a number or just D, a letter, we're going to use that whole value, 11x minus 2. So I'll demonstrate this first one. If I'm doing all of these 4 added together, I'm just going to rewrite those 4 and add them together. I like to put my x first. You don't have to, but I like to. So I'm going to write 11x minus 2 plus 94 plus 94 plus 86 equals 360. So once we have this equation written out, any ideas of what we would do next? Combine like terms. Good. So what like terms do I have? Got my 94, my 86, and there's one more.
-2.
-2. Yeah. Now, whenever we have that -2, -2, however you're looking at it, a lot of people, this mixes you up because we forget that we need to include that minus. So make sure that when you're typing it in, you're putting this in as -2, plus 94, plus 94, plus 86. That, or you could add the three big numbers and then do subtract 2. Plus 94, plus 94, plus 86. And I got 272. Are you guys getting the same? Yep. Good. Good. Okay, so I'm going to cross those out. And what comes down? Good. 11x plus 272 equals 360. What should I do now?
Subtract 272 from both sides.
Good. Minus 272 on both sides. Bring down 11x equals
88.
88.
And then you divide.
And then you divide. And we get x equals 8. 8. Good. So that's number 9. And that's, it really doesn't get a whole lot more complicated than that. So if, that didn't feel too terrible, then you're in a good place. If it did feel terrible, we'll do some more practice. Okay. Any questions about that one? Or we feel good about it? Good. Okay, let's do one more together. Number 10. Anybody have an idea what equation I could write to begin this one?
So 10x plus
17x plus 8 plus, say it again, 110. Good.
66.
Yes, perfect, perfect. Add all 4 together, they equal 360. Yes, we add that 8 and all the other like terms. So we have 1, 2, 3, 4 like terms here. So let's see, 8 plus 110 plus 74. 66. This number, 58. You guys get the same?
Yep.
Good. Bring down equals 360. I'll bring down 17x plus 258. Good, minus 258. 17x equals 102. Last step. 517.
6.
X equals 6. Yes. Great. Good job. Okay. I would like for you guys to try number 11, 12, 13, and 14 on your own. Okay, so I'm going to set a 10-minute timer. I think that should be plenty enough time for you guys to finish them. And when that timer goes off, the bell will be ringing pretty close to the same time, and you guys will get a little break. But I am gonna pause this video, set that timer, and I want you guys to try those on your own. Okay. All right, so you guys were supposed to do numbers 11 through 14 on your own. Let's see how we did. So for number 11, okay, good. For number 11, shout out some of the answers that you got. What'd you get for X?
5.
5? Everybody got 5? Good. Number 11, X equals 5. Number 12, what did we get?
6.
6. Wonderful. 13?
3.
3. It's okay. 14?
8.
8. Awesome. Equals 8. Wonderful. Okay. Awesome. How did that feel? You guys feel okay with them?
Yep.
Good. Good. Okay. So, it is 2:00. We are right at break time. If you did any of the problems at the bottom of the page, we can look at them when we get back from break. But we're gonna take 15. So we will start back up at, it's now 2:01, 2:16. We'll start back up. So take a break, stretch your legs, go to the bathroom, get a drink, whatever you need. And we'll be back in 15. All right. We are back from our break. And did anybody attempt number 15 through 18?
Yeah.
You did? You did? Okay.
Okay.
Let's see. So number 15. First, what did anybody get for X?
0.
You got 0? You did too? Okay, so let's write that. X equals 0. And if X equals 0, it says find the measure of the angle indicated. So it wants to know angle Y. If I want to find the measure of angle Y, how could I use my X value?
You plug it in.
Plug it in. X is right here, so 2x. Instead of x, we'll use 0. So 2 times 0 plus 118
Is 118.
is 118. It just gets rid of that 2 times 0 is just 0. So the measure of angle Y is 118 degrees for number 15. Awesome. So you just plug the x value in. Okay, did any of you find x for number 16?
Yes.
What'd you get?
9.
9. Anybody else do 16? You didn't get there? Okay. I'm sure 9 is right. Just to be certain, let's see.
Yeah, I very well could have missed the numbers.
I'll try to do it really, really fast. 82 plus 105. 82 plus 105 plus 11. So there's that one, that one, that one. 198 plus 8x plus 10x is 18x plus 360 It's minus 198 on both sides. 18x equals 162. And x does equal 9. Perfect. Okay, so if angle F is 10x and x is 9,
10 times 9.
10 times 9, 10 times x, 10 times 9. So angle F is how many? 90. Good. 90 degrees. Nice. So all that we're doing here is just one additional step. Once you find x, you just plug it back in to the value you're looking for, and that's how we find the missing angle. Did anybody get further than 16? You went further? Okay, let's see. 17, what did you get?
I got also x equals 9.
Okay, x equals 9. So let's see, 95 plus 95 plus 13 is 5. It's the same problem. Because whenever 10x and 8x makes 18x plus 198 equals 360. That's the same problem we had written for number 16. That's hilarious. So yeah, x equals 9. And then measure of angle M.
I got 85.
See, 10 times x is 9 minus 5. That's 90 minus 5. That is 85. Good. Perfect. Okay, did you get to 18?
I did. I just finished that.
Okay, what'd you get for x?
I got 8 for x.
X is 8. Let me just double check. -7. It's 2 plus 3 plus 60, 11, 14, 15, x.
It makes 25.
Let's see.
It makes 25x.
Wow, thank you. Mental math.
I was like,
wrong.
wait, I did get that one wrong.
No, I got it wrong. I can't do math fast. I'm slow and steady. So 360 minus 160. 25x is 200. 5. Yes, x equals 8 is correct. And then angle M.
I got 86.
1 times 8 minus 2. That's 88 minus 2 is 86. Good. Perfect. All right. If anybody wants to have these answers written down, maybe you want to go back and work them out later, totally up to you, completely optional. Again, I'm not collecting this for a grade, it's just good extra practice. But I'll leave this up for a second and I'm going to get that door shut. And we're going to pull our notebooks out and take another little section of notes. We're going to talk about a second topic today. So let me pause this, close the door, and I'll be right back. So I am going to put this worksheet to the side for now and pull my notebook back out. And we just took notes on quadrilaterals and the sum of those angles always being 360. Then we specifically talked more about parallelograms. Now we're going to move on to the next page. I'm going to title this Page 17, Notes Continued. Page 2. And we're going to talk now about specifically parallelograms, area, and perimeter. So, area and perimeter. parallelograms. Okay. Now remember, a parallelogram is a shape that has opposite sides equal, opposite angles equal. Doesn't necessarily have to be that tilted shape. A parallelogram is any four-sided shape that follows those rules. So that could also include a square. Those opposite angles are equal. Those opposite sides are equal. It could also be a rectangle. Opposite sides are equal, opposite angles are equal. It could also be a rhombus. That looks like a diamond. All four sides are equal. To start, we're going to talk about area. And I'm going to give you a formula. And before I give you that formula, I want to make sure we know what area actually is. I'm sure that you were probably taught about area a long time ago. Does anybody remember what area refers to?
The whole space inside the shape.
Exactly, it's the space inside of the shape. So, area is the space inside a shape. And inside of a shape, whenever we talk about the space, when we measure the area of a shape, we're not measuring a length, we're measuring space. So we don't just say, for example, inches. We're talking about square inches or square meters, square yards. So whenever we are talking about area, I'm going to write in parentheses units squared. I put a little squared right there. Units meaning inches, meters, yards, centimeters, whatever's given to you. And we find area using the formula A for area equals B times H, where B means base and H means height. Some visual examples. I'm actually going to use some colors here. Green for base, red for height. If we were talking about a parallelogram that looked like a tilted parallelogram, kind of the stereotypical one, we'll draw a picture of that. And it doesn't have to be perfect. I'm not using a ruler here. So for example, on this parallelogram, my base is always going to be this bottom side length. With tick marks that base is also, because it's a parallelogram, opposite sides are equal. It's the same length as the top side length. So technically we could also label the top with a B if you wanted to, but I like to think of it as being the bottom. B for base, B for bottom. Now, you might think that the height would be the shorter side length, but that is tilted. The height is always the length from the base. What was that? I was like, are we getting an announcement? Okay. The height is always the length from the base up to however tall the shape is, but it must be going at a 90-degree angle. So this is not a 90-degree angle. What we do instead is we draw a line. Sometimes you'll see it inside of the shape, like a dotted line. Sometimes you'll see it outside of the shape. I could do another dotted line here. And there will be a box showing 90 degrees. Both of these lengths would be considered the height. Not the same as the smaller side length. It's going to be different. Now, more specifically, this is a parallelogram. Another type of parallelogram we might see would be like a square. Or how about we start with a rectangle? I'll draw two shorter sides. And a rectangle has 90-degree angles, so we want to try to make them straight up and down. We use the same area formula. But this time, our height is the same as the shorter side lengths. And that's only because it's already a 90-degree angle. All four of these are 90 degrees. So the height can be here. These can be down here. Now, if you want to make a note, maybe about the height, just say height must be at a 90-degree angle. If it's not 90 degrees, it's not the height. So, highlight that formula just so it kind of stands out. Draw a little box around it. That's our area formula. Below that, we'll write perimeter. So area is the space inside of a shape, and we measure area in units that are squared. Does anybody know what perimeter refers to?
Around the shape.
Yeah, it's the space around the shape, and it's specifically a length. This is a length that measures the distance of from one point going all the way around one side, the next side, third side, and the fourth side back to that original point. So we're going to say instead of the space, we're going to say the distance or the length. The distance slash length around the outside. of a shape. These units are not squared. So perimeter would just be inches or centimeters or yards, miles, meters, not squared. So I'll write in parentheses down here, units not squared. There is a specific perimeter formula. However, there are other ways to find perimeter. One of the simplest ways is to just add the 4 side lengths together. So side plus side plus side plus side, or base plus side times 2, since there's 2 pairs. I'm going to write the official formula for you. So perimeter equals, and we don't use height because height sometimes is not a side length, sometimes it's just a specific distance in the shape. Instead of height, we'll use side, S for side. So I'm going to start with 2 and then parentheses, so 2 times base plus side. And E is base, S is side. Some colors I'm gonna make might be green, same as area. And then side, I'll use blue, a light blue. You could draw a whole nother picture if you want. You do not have to. You could also, I'm gonna go back up to the area pictures I drew, and I'm just gonna highlight the side with blue and write S. This could also be the side. In rectangle, the height will be the same as the side. So,
A square, they all the same.
yes, if you had a square, all 4 sides would be the same. So instead of this formula, we could say 4 times the side, since it's 4 sides. So there's the formula. We could also just say add all side lengths together. I'm never going to require that you use the perimeter formula because I don't know. Whenever I was in high school, I didn't ever use this formula. I was always just told add all the sides together. And that works. This works too, though. So you have both options. Okay. So we have those 2 formulas. And what we're gonna do, let's see. I'm gonna give you, I believe I have another paper to give that. Okay, we're gonna do some drawing. So if you don't want to have to flip back and forth in your notebook, you could do what I'm about to do. I'm going to copy down both of these formulas on a sticky note. That way I can move it to the next page. Area is base times height. Perimeter is 2 times base plus side. Base is here. Height is here. Side length is the side length. Or this could be the side. Or this would be the base. And do you guys see where that perimeter formula comes from now that we have both bases and both sides labeled? We're taking a base plus a side, but there's 2 of them, so we take it times 2 instead of adding 4 numbers. Base plus side times 2 gives us the other base plus side. So we're going to do some examples, and I'm going to flip my page in my notes and give you some. Day 17 and change. Page 3. Area and perimeter. So we're going to start for 1 with a shape that looks like this. Where the base down at the bottom is 6.2 inches. And the side is also 6.2 inches. So you have these angles, all 90 degrees. What kind of shape would this be?
Square.
A square. This is a square. A square is a specific type of parallelogram because our opposite sides are going at the same angle. Our opposite angles are equal. Our opposite sides are going to be equal too. Square. Okay. So if I wanted to find the area of this square, how could I do that? Say it again.
Base times height.
Base times height. Area is base times height. What's my base?
6.2.
6.2. Okay. And my height?
6.2.
Also 6.2. So we're just going to use the area formula. A equals base is 6.2 times height is also 6.2. We'll just multiply. So what is 6.2 times 6.2? $38.44. So area equals 38.44. Now our units were inches.
Squared.
So good, our area will be inches squared. Now, if I want to find perimeter, what should I do?
Add all four sides together.
You can add all four sides together. You could also use the formula if you want, but adding all four sides together works exactly the same. So perimeter equals, see, all four sides are 6.2. So I could do 6.2 plus 6.2 plus 6.2 plus 6.2. Is there a faster way?
The other one you wrote on there. 6.2. Yeah.
You could do this, the
Just
formula.
do
6 times 2.
4.
There's a way faster way. You can do 6.2 times 4. Yeah.
24.8.
So 4 times 6.2. And we get, what did you say it was?
24.8.
Perfect. 24.8. What's our units?
Inches.
Inches. Just inches. That would be our perimeter. Nice. Nice, nice, nice. Good, good, good. Okay. Now, this time I'm going to give you one that's a little bit different. Let's do a parallelogram that looks like the classic parallelogram. So a tilted line along. Not perfect, but you get the idea. And I'm going to give you a few measurements. Dotted line through it and label this measure with 4.6 inches. We're gonna label the bottom with 9.2 inches. We'll label the side 4.8 inches. You find the area of this shape. How would I find the area of this shape?
Base times height.
Base times height. So what am I using for base and height?
Base is 9.2.
Mm-hmm.
Height is 4.6.
Perfect. So base is 9.2. Height is 4.6.
Equals 42.32 inches squared.
Good. 9.2 times 4.6. Yes, 42.32 inches squared. Perfect. Okay, so we've got area. How about perimeter?
I did 2, and then in parentheses 9.2 plus 4.8.
Good. 2 times the base is 9.2 plus the side is 4.8.
I got 28 inches.
Okay, so let's see. 9.2 plus 4 times 2. Perfect. 28. So our perimeter is 28 inches. Good job. Good. How did we get the first perimeter?
No.
Or on numbers? For area of number 2? Yeah, so we did 2 times the quantity of 9.2 plus 4.8. So there's 2 ways you could work it out. You could either add first, since it's in parentheses, or you can distribute and do 2 times 9.2 plus 2 times 4.8. See, 9.2 times 2 is 18.4. 2 times 4.8 is 9.6. Add them together.
Don't give me the thing.
It should give you, yeah, the same answer plus the 4. Yep, and we get 28. And on your calculator, another thing you can do, if you don't want to have to do a bunch of steps, as long as you type your parentheses, you can do it all in one step. So I could type 2 parentheses above 8 and 9. So there we go. 2 parentheses 9.2 plus 4.8. Close your parentheses. Enter. Gives you the same answer. So using those parentheses can make things go a lot quicker. Good. Okay, and did that fully answer your question? Okay, perfect. Perfect. All right. Let's see. No, it is. I'm going to give you one more, and I want you to do this one on your own, which y'all kind of have been doing anyway. And after this one, we're going to start thinking about an exit ticket. We're almost at 3 o'clock. 3:30 is the end of class. But we got through a lot more than I was even planning. Good. Let's see. Third one. I know, a little class. When you don't have many students, things go by really quickly.
This class is way smaller than the last one.
Yeah,
It
it is. Yeah, for some reason, I usually have a huge algebra 2 class, and geometry's typically a lot smaller. Why? So this time, this is 5.07 inches. This one is 6 inches. And this is 4.7 inches. And I'm going to freeze my screen and I will work it out on my own. Give you a few minutes.
Find both of them?
Yes, find the area and the perimeter, both of them. So I'm going to pause this, freeze my screen. That way you can't see me doing the work. I'll unfreeze it, show you my work. You guys can compare. Okay, that's what I got. Area 40.42 inches squared. Perimeter 27.34 inches. Did anybody get something different? Got it? Good. You guys get anything different?
For the last one.
For the parameter, okay.
I don't know what I do wrong.
So for your work, do you have the same thing written down?
I don't think that's right.
And you wrote 2 times 8.6 plus 5.07?
I might have typed it in wrong.
Look at your calculator and see if it looks like that.
Oh, I didn't use the parentheses.
That'll do it. That'll do it. So type it in with the parentheses, and I just want to make sure you do get the same number. See if that works. Perfect. Good. Good. Awesome, guys. Okay. Let me give you a little challenge problem. This could be some kind of bonus in the future, maybe. Let's say I give you that the area of a shape is, let's say it's 345.2 inches squared. And I also tell you that the base is 12.5 inches. What we're missing here is the height. If I wanted you to solve for the height, do we have any ideas of how we could do that?
Would you divide 345.2 by 12.5?
You would. You would. Now here's why. Because sometimes just looking at this, it's like, where does that come from? If we were to look at the area formula, remember it's area equals base times height. If we plug in the values that we do know, we can then solve for the values we don't know. So area, I already know, is 345.2. So let's plug that in. Instead of A, 345.2 equals, we don't know our height, but we know our base. We know our base is 12.5. So I'm going to write, instead of B, 12.5 times height, which this would just be like 12.5x, 12.5h instead. Anytime we have a number attached to a variable in an equation, the way to detach them is to use your inverse operations, your opposite. So if this is 12.5 times height, the opposite of that would be to divide by 12.5. That'll give us our height by itself. So we'll do that on both sides. Divide by 12.5. Divide by 12.5. Bring down the height by itself equals, tell me when you get an answer.
I got 27.61.
Okay, let me see if I get the same.
27.6?
Perfect.
That's what I got.
I got 27.616.
Yep.
Perfect, perfect. I would take, on a quiz, I would take 27.6. I would take 27.6162, or you could write the whole thing, 27.616. I'll write the whole thing just so I have it. And what would my units be?
Just inches.
Just inches. Good. Inches. So that would be our answer, 27.616. So we can use these formulas in a lot of ways by rearranging problems, solving for different values. But that's just a little bonus thing. So I'll write bonus right here. All right. Okay, guys. So what you are gonna do is you're gonna give me a second, and I'm gonna make you your exit ticket for today. And I'll make copies of it and pass it out, but if you want, you can watch me make it. So give me just a moment here, I'll pause this. Here is our day 17 exit ticket, so it's in the video. And I am gonna go run copies of this. Again, if you're writing this yourself, feel free to start working on it. Just please label that it is day 17, and I will be right back with those copies. The end.